I'm Howell, and I worked as a quant for 4 years where I used complex math models in order to beat financial markets. And here are some questions that filter out over 90% of applicants. And this is starting off with a two-parter. First, we're going to be playing a dice game where I give you a fair 6-sided dice numbered 1 to 6, and I'm going to pay you $1 per number that you roll. So if you roll 1, you get $1, and if you roll 6, you get $6. And I'm going to charge you $3 to play this game, which you can play with me for an infinite number of times. How much money would you put into playing this game? In a previous video, I showed how the expected value of a single dice roll is just 3.5, so you expect to make $3.5 off of rolling a dice, but you pay $3, so the net amount that you make is 50 cents, which is still a great amount of money for a single dice roll. I'm just going to say $100, but honestly, you can say any amount as long as you express that it looks like a great game and you're really happy to play it. Now here's a tricky second part to this question. So instead of paying you $1 per number that you roll, I'm going to pay you $2. So if you roll a 1, you get $2, and if you roll a 6, you get $12. And instead of charging you $3, I will be charging you $6 to play this game. Now, how much money would you put into playing this game instead? There are two very common mistakes that people make when answering this question. First are the people who say that since the reward scaled up, that they would just put in double or more money, and that's clearly wrong because the risk has also increased too. Second, there are people who say that the reward scaled up with the risk, so therefore they would be putting in the same amount of money, but that is wrong too. An easy way to think of why is to scale the game up by a factor of 1 billion rather by a factor of 2. So you have a chance to win 1 to 6 billion, but you must pay 3 billion to play this game. And okay, maybe you're lucky enough that you can borrow $3 billion to play this game, but even then, the non-negligible likelihood that you'll lose $1 billion plus is so high. It will put you into generational debt that will crumble your entire family tree, and therefore you shouldn't be able to play this game. And that gives us a sense that as the game scales up, then we should be putting in less money into the game. And therefore, the right answer is a smaller bet. Mathematically speaking, we should scale our bet size according to the ratio of the reward divided by the variance, and while the reward has doubled, the variance has quadrupled, and therefore we should bet half as much before. So if I said $100 before, I should say $50 now. This is based on the Kelly criterion for mathematically optimal bet sizes, and follow along for more fun math content, and I'll go into more detail in mathematically optimal betting in the future. But to end things off, I don't think you have to know the formula, but you should have some intuition that you should be scaling your bet sizes down.